Okay, this is the MATLAB window, and what I'm going to try to do here is just work with you, just do a very, very simple filter um, building. So I'm going to open an app called Filter Builder, and once I open this app, I'm asked whether I want to uh, design a low pass, high pass, band stop, and different kinds of filters. So I just say that I want a low pass filter, okay, and I say okay, and again I get a lot of options here. I'm going to design a finite impulse response filter, and let's just leave all this as such, and I'm going to use frequency units which are normalized frequency units. Okay, and I'll have to tell when I'm doing a normalized frequency. I will have to say, well, what passband frequency do you want? Remember what passband frequency is? That's the band of frequencies from which the signal is passed, and which is the stop band frequency. So the frequencies that I have are from 0 to 1, and I'm going to pass all frequencies from 0 to 0.45, and 0.55 to 1 will be the frequencies that are stopped. Between 0.45 and 0.55 is the transition band. Okay, so that's how this works. So if you're designing a filter where you have a specific frequency in your mind, then the sampling frequency would the half of the sampling frequency, sorry, would be 1. It would be normalized to 1. Okay, you could also choose frequencies if you want to here, but I'm just going to leave it at normalized frequency right now, and I'm going to say, well, I want to do normalized frequency, and let's say I want to view the filter response. Just give it a moment. Well, it says apply, yes, and let's visualize. Give it a moment, um, and hopefully it opens up. Yeah, there you go. So that is my frequency response. That is my FIR filter that I get, right? So you can see that I've got a pass band here. There's a small ripple in the pass band. There is a transition band, and there is a stop band. And I'm getting a difference of what? 60 dB, which is quite a lot. Okay, so that's how my filter works. So you can see that this is normalized frequency into pi radians per sample. So 1 corresponds to pi, which also corresponds to the highest frequency in the signal, which is fs by 2. Okay, now uh, let's just go back. Let me just close this and take a look. There is a design method that I have chosen here, and there are some design options which you can choose, which helps MATLAB to design different kinds of filters. And what I had said was I wanted a stop band attenuation of 60 dB, which I already got. Now if you do that, then you can actually generate a code that you generate the a code which gives you the filter, which has got the weights for the filters which you need. Okay, so let's write okay, and if I click here, okay, so I get so you can see that there is a filter structure. It's got 43 elements, and if I open this, you can see that these are the filter coefficient values that I have. Okay, and I don't know how to move to see all. Well, but you can see that there are these 43 elements. So it's a 43. It's the order of the filter is 43. So there are 43 terms that you add up to give your output, and that gives you the filter that we had. Okay, now let's go back to our filter builder and let's do a simpler exercise. So we'll do low pass again, but in this case what we'll do is we'll try to specify the the order of our filter. So let's start with second order. So we'll say what I want is I want a two order filter. So just take two inputs and add them together. Okay, and we'll aim for the same stop band frequency. Of course, you really won't be able to get that. Well, it says filter order should be greater than 3 in this particular tool. So let's say 3 and we say apply, and let's view the filter response. What do you get? Give it a moment. And can you see you get a similar filter like you got before? This is not a very good filter, is it? And now what we can do is we can increase the filter response, and let's just close this and increase. Let's say we go to order 5, just to make it a little more complex, and let's look at the filter response. And you can see that it's improved a bit, but this pass band, the stop band ripple is still very high. It's at 10 dB, which is not bad. It is some kind of a filter, but it's not really a very, very good filter, right? You can increase this. Let's say we make it order 10, and let's see what we get. View filter response, it says yes. And you get a slightly better filter here. So you're getting a stop band ripple of around maybe 17 dB or so. And there is a ripple in the pass band that has come in. So you can see that as I start adding more and more terms, I get better and better filters. And you could use this tool to design some filters. And what I'm hoping is that this course just gives you some basic idea of how you can be designing these filters. Though I'm not really going to require you to design filters of this kind. Or maybe I will.